Hello, in this video I'd like to show some of the features of Maple that are very helpful for working in linear algebra. And if you're just starting a linear algebra here at SUNY Empire, many of these tasks you would not need to do for your first Maple assignment because your instructor may provide you a Maple file that's already set up for you. So I'm just going to go through the tasks as if you're starting from a brand new Maple file. So when you open Maple, you have a choice of a new document or a new worksheet. And documents are much easier to work with, so I'm going to choose New Document. Also, if you notice this panel on the right side, you can minimize that with these little arrows and close that context panel. Now, if you're working in linear algebra, you want to load the linear algebra package. To do that, I'm going to go with parentheses, capital L, linear, capital A for algebra, and now Maple knows what I want to type. So I'll hit Tab and I'll close my parentheses and hit Enter. That blue output lets me know the package was loaded. It does clutter my file a bit, so I can suppress that output with a colon and hit Enter. And now it's loaded, but it's just hidden from my view. I'm also going to find it very helpful to load another package called With Solve Tools. And I'm going to put a colon there to suppress that output. Now, you might be wondering, how did I know to load those packages? And the way I knew that I needed those is that I went in the Help menu, and I've worked in this system a long time, so I know what packages I need to load. But if you didn't know, you would go in here and you'd say, okay, I want to solve a system of linear equations, and you start to see that there are a lot of options in here. When you click on an item in the table of contents here, there's a lot of detail, more detail than you actually need. But what's really helpful is when you get down to the examples section. So for example, if I wanted to solve a linear system, it gives me some sample code, and I noticed that they did load a package there. That's how I knew that I needed to load that. So let's go back over to our file. I'm interested in solving a system of equations. So let me type in text mode what I'm going to do. Okay, so to type up my equations, I'm going to be in a non-executable math mode, and that allows me to hit Enter after each line without any output or error messages. Notice if you typed in something like x plus y plus z equals 3, and I was in math mode, and I hit Enter, I'm going to get this blue output, and that doesn't really make sense. It's like Maple's just spitting back the thing that I typed in, and so that's cluttering up my file. I don't want to do that. So the message that I'm emphasizing here is that when you're just typing up your problem, you want to be in the non-executable math mode. Now, if you want to go and solve the system, you need to be in math mode. So let's go and do that. I'm going to be in math mode, and to solve the system of equations, I'll go back over to my sample code here. Here's an example where they have a system of equations in 3 variables. I'll copy paste that. I am in math mode, so that's good. Now, I need to adjust my problem a little bit. If I want to convert this to a homogeneous system, my first equation would be x plus y plus z minus 3 equals 0. My second equation would be x minus 2y plus 3z minus 11 equals 0. And the third equation is just exactly what it is because it already was equal to 0. So I don't need to do anything different. That means when I type them in to my executable line, I need to type them in this form. So I'm going to type x plus y plus z minus 3. Then I've got x minus 2y plus 3z minus 11. And my third equation, so I put a comma there, x plus y minus 2z. And I hit Enter. I'm in math mode. I'm expecting an answer. and indeed, Maple gives me an answer. Now, suppose I wanted to go in and solve this with a matrix. So maybe I'm looking for reduced row echelon form. So I type in RREF, and if I look down, there's a lot of detail. I don't need all of that detail, but it shows how to call the linear algebra package, which we already did. It shows how to type in your matrix of coefficients, how to type in the column vector, which would be all the solutions, and then how to do your reduced row echelon form. Let's go through and do that. Now, you can use this notation with the angled brackets. I'm a very visual person, so I actually like to go down here and use the insert matrix option. So I'm going to say matrix A colon equals, and now I'm going to insert a matrix which is a 3 by 3. And so in my first position, row 1, column 1, I'm going to type a 1, and that's because I've got a coefficient of 1 on the x. Next, the coefficient on the y is going to be 1, and the coefficient on the z is going to be 1. I'm only doing my coefficient matrix, so now I'll move on to the second equation for row 2, and that's going to be a 1, negative 2, and 3. And the last row, my third row, is going to be a 1, 1, negative 2. And I am in math mode because I'm taking this 3 by 3 array, or this matrix, and I'm setting it equal to the variable called A. I want to call this matrix A. So when I hit enter, I get back that kind of same input. That tells me that Maple understood what A is. In fact, I can type in A and Maple will tell me how this is what A is equal to. So that's very reassuring. Now, for my column vector B, I'm going to type B equals. This is going to be 3 rows and 1 column. And this is my column vector of answers, or values 3, 11, and 0. And I can just confirm, indeed, Maple knows what B is. I can copy paste this command, reduced row echelon form A joined B. I am in math mode, so I'm expecting an answer. And indeed, what I find is that 1, so in other words, 1, let me get in non-executable math mode, 1x equals 4. In other words, x equals 4, and that's exactly what Maple told me up above. This tells me that 1y equals negative 2. And lastly, the third row tells me the third column, that's variable z, 1z equals 1. And again, that's exactly the same solution that I got up here. So this is a nice way of showing you can get the same answer in 2 different ways using technology. If you are working on your homework, you're welcome to use either method. I highly recommend that you can do these problems by hand, but if you get a really large matrix, like a 10 by 10 matrix, you don't want to do that by hand. So it is very important to understand how to use technology to solve some of the very big linear algebra problems that you might encounter.